So, good morning, everyone. I'm Arthur Guichet, Secretary General from the European Water Association, and welcome to today's webinar that's jointly organized by EWA and the Joint Research Center from the European Commission on water reuse and EU competitiveness. I will directly give the floor to you, Roberta.
Thank you, Arthur. Good morning, everybody, and thank you for joining this webinar. This time it's our workshop on water use is jointly organized with the European Water Association. I will give an introduction of the Joint Research Center of the European.
Roberta, I'm sorry to interrupt you, but we don't hear you very well. Do you have your mic? Yes. Thank
Sorry,
you.
I put it up for the
Yeah.
picture.
Much better, thank you.
Yes. Yeah, good morning again, everybody, and welcome to our water use webinar. This time jointly organized with EWA, European Water Association, which I thank very much for the support. So I'm Roberta Maffettone. I'm a scientific project officer of the European Commission Joint Research Center. As you might know, many of you, is the Commission Science and Knowledge Service that provides scientific evidence throughout the European policy cycle. In particular, I work for the unit Ocean and Water that is located in Ispra, Italy. And my team, known as the Water Lab, supports policy development on water use and wastewater surveillance, but specifically I'm working in and supporting the implementation of the water use regulation and also promotion of water use in the European Union. Yeah, next. As many of you have heard, the European Commission is currently working on drafting an initiative on water resilience strategy. This is because water became one of the main objective for the next Commission to address water scarcity, but also to enhance the competitive, innovative edge of our water industry and take a circular economy approach. This is why next, beyond supporting the member states now in the implementation of the water use regulation that apply for agricultural irrigation, we are exploring also water use beyond agriculture. This includes also industrial processes, urban landscaping, and environmental restoration. And for the topic of this webinar, we are looking at how industries are facing water scarcity and are looking into reusing municipal wastewater or processed water within their industry to support their water needs. And this, of course, will have greater benefit, will enhance, of course, water conservation, but also will have effect on innovation and market expansion and support the European competitiveness. Next.
Yep.
So the JRC, JRC technical workshops on water use, workshops and webinars. We have been organizing them since the last 3 years to share knowledge and best practices by bringing experts and stakeholders together. We have organized many on risk management approaches, and we are still currently organizing some of them by looking at what the member states are actually doing in drafting risk management plans. So we will have many upcoming now that the member states are implementing the regulation. We had other 2 or 3 on industrial reuse. In addition to this one, we also had a workshop on amenity-related environmental applications, and also looking at the risk assessment for contaminants of emerging concern. The aim is to collect case studies from all the European Union. We will have a next workshop, so save the date, on 22nd of May at 11 a.m. CEST, CAECT, jointly organized with the Water Use Europe Association. And we are also currently preparing a web platform on water use that we are expecting to be published by June 2025. And also this is in collaboration with the European Water Association. We are currently working on to envision a European Water Academy that will have a pillar on dedicated to water reuse. This is to cover the training requirements for skills and capacity building needed to implement the water use regulation and also the other policy on water. And I will give back the floor to Arthur.
So thank you very much, Roberta, for those kind words and also the mention about the EU Water Academy. Before we start with our three speakers for today, please allow me to quickly present the European Water Association. EWA, we are actually an independent, non-governmental and non-profit organization dealing with the management and improvement of the water environment. We have members from nearly all European countries, and we actually offer three types of membership. So national members for national association, either dealing with drinking or wastewater, sometimes both. And they all mainly represent so water operators, water workers, also set up technical standards in their countries and so on. We also offer corporate members, and we cover more or less a wide range of the water sectors, between going from pipes to pumps to sensor monitoring or digital twinning programs and so on. And we also have research members, so mainly EU universities dealing with water. And due to this wide range of members, we also see ourselves as a forum for the key discussion on technical and policy issues in Europe, and trying to bring everyone around the same table. And we also organize conferences, workshops, meetings. We have internal working groups, also supporting the EU Water Academy discussion currently going on with the JRC. And we also have some online events like the one from today, on top of newsletters and so on. And quickly, before I stop sharing my screen, a quick info for today. Please use the Q&A box to submit your question to the panelist. All of us can see it, but it's still better if you mention to who the question is addressed. We'll use only this. We cannot use the raise hand and switch on your camera and mics as participants, so please use it. You can have the chat box if you want to share some comments with you, but please focus on the Q&A. It's easier for us on our side to handle. And as you see, this meeting is recorded and will be shared with you, and the PowerPoint should be also shared with you. So thank you very much for this and for this quick introduction. And we will start now with the first presentation from Dr. Dirk Wittenberg, Senior Vice President, Strategic Business Unit Water Treatment. His presentation is Hydrogen and Rainwater Utilities at the WILOPARK. Dr. Winterberg joined WILO in 2021 as Senior Vice President SBU Water Treatment. Previously, you had worked at Remondis, one of the world's leading industrial companies working in the field of water and wastewater management, as well as recycling. And you have profound knowledge in post-merger integration and lead several companies in India, Turkey, Spain, and France. And you hold a degree in civil engineering and a doctorate degree in water management, hydrology, and hydraulic construction. And again, your presentation will be on hydrogen and rainwater utilization at the WILOPARK. As agreed before, I will share now my screen from my side with your presentation. Please let me know if there is any issue with the presentation. Thank you, Dr. Wittenberg. The floor is yours.
Thank you, Arthur. And thank you for sharing your screen with my presentation, our presentation. Thank you very much, first of all, for giving us the opportunity to talk about our sustainable WILOPARK achievements, which we realized during the past years with special concentration on fulfilling some of the main topics of the sustainability goals. Creating, caring, connecting is the headline of our strategy overall, which is guided by the word sustainability. Next slide, please. Our business is divided into mainly into 3 market segments. One of those is building services that covers equipment around technical equipment of all kind of different buildings. Water management activities are the second market segment in our range of services that covers several activities and devices around movement of different kinds of water, cold water, hot water, wastewater as well. And we are providers of a huge variety of industrial applications for the global industry. Our innovative solutions, smart products and individual services move water in an intelligent, very efficient and climate-friendly manner that is guiding our activities always. Next slide, please.
Yeah, just a quick question. Do you still see the black lines on the presentation when I share it or not?
Yes.
Yes, okay, sorry. So give me a second. Roberta, I saw you wrote to me on the chat, Zoom setting, sharing, navigated, advanced setting. Wait, sorry. Okay, so let me stop sharing and I will do it. I will close some programs in the background. Up, close. And Roberta, you said so shared. PowerPoint, sorry, up. Okay, so let me do and try again. And I will reshare the presentation directly, and I hope it will be fine. Is it better?
There is still a black.
Yeah, we still have this black block.
Okay. We share the presentation. So because otherwise, Dirk, what we can do is you share it on your side, and for the video, I will just retake over. Okay. I'm really sorry about it.
Okay, let's try that. Just a second. Can you see it now?
Yes. Thank you.
Okay, so let me continue with the presentation. We are an international premium manufacturer of pumps and a world-leading driver of innovation. The close proximity to our customers and partners is a very necessary target. With our wide-ranging and efficient network of production and sales companies close to our customers, WILO also has a contact point for your questions and requirements close to you. Our locations worldwide, you can see on the presented map, we are present with production sites, 16 production sites around the world on every continent, and a variety of representative offices as well as, well, production locations in Europe, in US, in Asia, and in Africa. Okay, now I click. Okay. Sorry. Yeah. Our new sustainability strategy is guiding our overall and global activities and overall development. Sustainability is governing our activities. We are following the mega trends of the environmental and mainly environmental developments around the world, and created out of that, governed by sustainability strategy, our ambition 2030. This ambition is divided mainly in 3 impact areas. We divide the impact area creating, caring as a second one, and connecting. Creating means we are offering sustainable solutions. In that regard, I would like to show you our main achievements, which we could achieve in the year 2023. Energy savings of around 2 terawatt-hours have been generated by our highly efficient WILO pumps. We received the best rating of the international rating agency EcoVadis with the Platinum Plus award, which we could achieve. We achieved a very remarkable benchmark level of accident rates in our production facilities. We could run an industrial conference during our international management meeting held in Singapore in November 2023. We could achieve a 17% reduction in Scope 1 and Scope 2 emissions since 2022. We established a very highly efficient recycling take-back process for old pumps from our customers to be exchanged by modern, more efficient pumps. We increased our net sales in the area of clean water treatment activities by 24%. And we have a very high employee engagement score, which is a good sign for us as we always try to be a very good employer. As I want to give you some examples from our sustainable solutions which we installed at WILOPARK, let me come now to the introduction to our highly sustainably efficient WILOPARK, which is our European and global headquarters here in our hometown Dortmund. What you see here as an aerial view is a rendering, but it is looking exactly like this today. And we are sitting here in an office in the factory building. You see the huge factory as the center part of our WILO campus. This factory is highly efficient and fully equipped with a lot of very modern and efficient technologies. We covered the whole roof area with solar panels where we are collecting renewable energy. We installed a rainwater utilization scheme. We are monitoring in real time all the processes and the currents of energy of any kind in the manufacturing process and in the running of the whole building complex of the factory and the administrative office buildings, which you see in the southern part of the WILOPARK. We are running the buildings with a very, very modern, high-level building management system. We are running a green hydrogen power plant, which we are feeding with the photovoltaic energy harvested on the rooftops of the factory. We have the biggest electric car charging park in our federal state here in North Rhine-Westphalia. And a growing part of our company car fleet is already electric cars. And the last building, which is about to be finalized by the end of this year, is a health center which will be ready to be used by our employees on the one side, but also of the citizens of the city of Dortmund on the other side. This is the WILOPARK. And let me give you some more details about our green hydrogen strategy. And thereafter, I will finalize my presentation with a short explanation of the way how we use the collected and harvested stormwater, respectively rainwater. Our strategy in terms of green hydrogen is to be explained by the following bullet points. The first one is green hydrogen is very fundamental for achieving the climate protection goals agreed in Paris. Green hydrogen has the potential to strengthen Europe's international competitive capacity. As a climate protection company and leading innovator, WILO has a social responsibility. WILO provides solutions to counteract climate change and energy shortages. And WILO is willing to become a global player in the creation and storage, distribution and utilization of hydrogen. When we started to consider a more detailed engagement in terms of green hydrogen solutions, we first tried to analyze where our activities, components, and machinery equipments are already participating in the hydrogen business. This is on the one hand in the wind power generation, as our servo motors, electrical motors are installed in the windmills, and as well our pumps are used for the cooling circuits used in the windmills. We are providing cleaning stations for photovoltaic power plants, and we are providing also the cooling of the solar cells and necessary drives. We are providing mixers for mixing the biomass in biogas production, heating pumps for waste heat, for example, in used and applied in greenhouses, are also part of our portfolio. And we are also providing pumps and components in the generation of hydraulic energy. Having that in mind, we decided to develop a system for so-called hydrogen power plants, which we are providing as a system integrator, providing the whole system containing the power generation, the hydrogen generation via electrolysis, the power generation out of the produced hydrogen via fuel cells, and the integration of, where possible, the process heat for the use of the heat, respectively use of the process heat as a cooling device where needed. As a source for the green hydrogen production, we can use any kind of renewable energy, if this is biogas or photovoltaic energy, wind power, or even power out of the wastewater treatment plants. Use for the provided and stored green energy could be used for the industrial running of the factory, like we are doing it here on site in Dortmund. It could, but it could also be used as a power for a hydrogen run truck fleet, or we could even feed the generated energy into the grid, and so on and so forth. There are several application possibilities for this type of decentralized hydrogen power plant. To show you what we have realized in Dortmund, I will explain you just the headlines of our installed green hydrogen power plant here on site in the WILOPARK in Dortmund. There we installed an electrolyzer capacity of 228 kilowatt. We are producing hydrogen, 4.3 kilograms green hydrogen per hour. We installed a 520 kilogram capacity storage combined with a fuel cell capacity of 76.5 kilowatt. And we are supporting the whole process with a battery of 158 kilowatt hours. What you see here is not a rendering, it is a photo of the inauguration of our hydrogen power plant, pilot plant on site in Dortmund, which was inaugurated on 9th of September 2022. And in following, we will give you a short overview over the process of the erection of our plant on site. And this is now your part here, Arthur, to run the film because it does not work with our presentation. So I stop the sharing.
Yes, thank you. Nope. Yeah. Dirk, the floor is yours to finish with the last slide on the rainwater utilization at the WILOPARK.
Sorry, Arthur, maybe you continue because we have troubles to
all good.
share.
Now you're good. Please go ahead.
Okay, you see the slide about the rainwater utilization at the WILOPARK. Can you hear me?
Yes, yes.
Okay. So last part of our presentation here today is giving you some insights of our way to utilize the harvested and collected rainwater at the WILOPARK. As I mentioned in the introduction, we are collecting rainwater on the rooftops. This rainwater, which we are collecting on the rooftops, is mainly used for the toilet flushing, gray water purposes within the factory. In addition, we are just about to introduce and to install an innovative concept for the storage pipelines, which we have installed on the under the parking lots and the roads of the park, because we have to store it and to discharge the collected stormwater of stormwater events, because infiltration into the underground is prohibited in the area because of industrial pollution of the soils. So we decided to not only discharge the collected stormwater from the traffic areas into the receiving river, but to collect as far as possible and use as far as possible the collected stormwater for the irrigation of the green areas, because we installed a lot of green areas and plants on the campus during the erection. And the next slide is showing you just a very rough overview over the drainage system. One part is the green roof retention volume that collected rainwater from the roofs is used for the toilet flushing, mainly in the factory. And the stored and collected stormwater from the paved areas of the parking lots and the roads is stored and collected in holding channels with an overall volume of nearly 700 cubic meters. This water will be used for the irrigation of the green areas on the park once we finalize the project. The project is pretty complex because we have to take care of a proper drainage system during stormwater events, and can only use the stored rainwater once it is not raining. But that is a question of steering, for which we developed a system together with a consulting partner out of the area of urban storm drainage management. Next slide. The system is nearly ready, and we will start the operation probably in the second half of this year. And this is just, again, one significant part of the realization of our climate neutral, sustainable WILOPARK in Dortmund. Whoever is interested to visit us here is always welcome to book one of the visitors tours. And yeah, that's for the moment all I want to explain. And next slide is the last slide, I think, Arthur. Thank you very much for your attention, and we are open for questions. Thanks a lot.
Yes. Thank you very much, Dirk. Roberta, do you want to say a few words? Do you want to take a first question now that we have on the Q&A? Take the first one for today, or do you want to move to the next presentation directly?
Yeah, let's do. There are some questions. Yes, thank you, Dirk, for the presentation. And thanks for the overview of the WILO park. We understand that water is part of water use is only one part of the multiple solutions that you are developing at the park for energy optimization. We see that the participants are indeed much more interested on the water use part. We saw slide that you were mentioning, I believe, wastewater use for hydrogen production. I don't know if you can say some more details about that.
You're muted, Dirk.
Wastewater use for hydrogen production is mainly
please.
Wastewater use for green hydrogen production is mainly referring to the production of biogas from sludge treatment on biological wastewater treatment plants, because the biogas which is produced out of this can also be a source for the feeding of the energy for the electrolysis. So you can store that in green hydrogen if you use the biogas and the generated energy for the production of green hydrogen. And that is
do you have a on-site wastewater treatment plant?
No. This is just a general. That slide has been giving just an example of possible applications. On site, we are using the photovoltaic energy, which has a capacity of 3.2 megawatt peak hours, and we are using the part of the collected photovoltaic energy, which we are not using in the manufacturing process, for the generation of green hydrogen. That is the energy source for the pilot plant on site in Dortmund.
Thank you very much for clarifying. We have some questions about the collection of collected storm and rainwater. One person is asking if besides irrigation and toilet flush water, do you use the collected storm rainwater also for other purposes, for example, processed water, and if you apply any kind of treatment?
We use the collected and harvested parts of the collected and harvested rainwater from the rooftop for the as the feed water for the hydrogen production. And of course, the hydrogen pilot plant includes a very highly sophisticated treatment of the rainwater for the process of the electrolysis, because that water has to be highly treated and has to be extremely clean.
And in terms of water balances, do you know how much percentage of fresh water you save with the collection of storm and rainwater?
I don't have the percentage in mind, but we definitely realize a significant reduction of the expenses which we have using public fresh water for the irrigation so far. So that's the reason behind it. But we did not yet really balance the total water balance of the campus.
Okay, and just I think last few questions. Is there any, well, I think you answered some of them. Arthur, do you think that those remaining questions have been answered? Because I think they are very similar.
Yeah, I think there was a similar, I think someone just asked on the first one, do you need to an analysis of the rainwater before reutilization? They mentioned toilet flushing, but if you run any of it, or do you just take it and treat it to the irrigation part?
The reason why we use the collected water, stormwater from the rooftops is that the expected pollution is probably lower than the pollution of the stormwater from the traffic areas. So the rooftop collection we use for the flushing of the toilets in the sanitary systems in the factory is not analyzed. So we are cleaning the tanks on a regular basis, and that's so far enough. We are running the factory since a couple of years now, I think since 5 years, and never had any problems. With regard to the irrigation and the stormwater collected out of the storage sewers under the traffic areas, we start without any further analysis, but we will have to probably to carefully monitor the effect of using the water for the irrigation of the trees and green areas here. So we are expecting some additional treatment necessities of these waters, which are collected well from parking lots. So there will at least be some micropollutants in it and minerals.
Thank you. And then I think one comment on the chat, but please, for any question, use the Q&A function. It's much easier for us to track everything down and to not forget anything. But again, on this, let's say we used water for the toilet flushing, and I think this one is a really concrete question. Just do you have any separate plumbing pipes? If you had any special ways or challenging to accomplish this, let's say, dual piping system?
Good questions. I'm not able to answer that because the construction of the rainwater using system for the factory has been executed before I joined the company. So I'm not the originator, but usually you have to take care very carefully of a separate piping system for the used stormwater. So yeah, it needs special efforts of the architectural and technological planning of a water supply system for a factory or also in the administrative building.
Perfect. Thank you very much. For the participants, please do not hesitate again to ask questions using the Q&A function. We'll move to the next presentation that will actually be a dual presentation. The first speakers will be Cyril Charbonnier, an engineer in hydraulic and working for SUEZ for more than 15 years. And you are now working at the headquarters of SUEZ as a market manager for water resources, aquatic environment, and by thus responsible for the wastewater we use offer in France, and by Johann Hagenmüller, a mechanical engineer and working for ETEX for 7 years. You are now working as an industrial director at ETEX, leading 3 manufacturing plants, including St. Loubès plasterboard plant in southwest of France. And in 2024, you connected the wastewater of SUEZ to St. Loubès plant. So you will give us an overview about wastewater reuse, French state of the art in 2025. And then Johan will present especially that plant and industrial use for water reuse. So Cyril, Johan, the floor is yours.
Yes, thank you. Hello, everybody. I share my screen. So I will talk about wastewater reuse in France. So that's like a state of the art from my window, let's say, from my window of SUEZ, which is one of the leaders of waste and water. I first present SUEZ fast. SUEZ is an international leader in water and waste.
Cyril, before you start, you are not on a presentation mode. We see your slide on the side. You're not on a full picture.
Okay, and why? Because on my screen I am. Now you don't see it.
No, we still see it into PowerPoint.
How could I do this? I don't know. I'll try to share my screen. Is it better
yes,
now?
Perfect.
Okay.
Thank you.
Excuse me. So SUEZ is an international leader in water and waste, present in more than 40 countries. France is our historical country, but we are present in Europe, Africa, Asia, and Australia, operating water services, waste services, and engineering and construction of plants, potable water plants, wastewater treatment plants, and waste plants. We are about a bit more than half present in waste, and like 40% in water, and about 60% of our activities in France and 40% in outside France. We are about 40,000 employees. So that's our identity. 40 countries, 40,000 employees. I will talk about what we do. This is what we do for wastewater reuse. But this is also what has to be done, because we do everything in that field. So first thing for water reuse is consulting and studies. Second thing is engineering and construction, and third thing is operation. Preliminary studies are very important because those projects have to be leaded by uses, by territory uses, and by evaluating uses and sources of wastewater. So it's very important and usually quite long to study that both uses. I present the French context. French context in reuse that we make some reuse for a long time, but we had like a wake up in 2022 because we had a very warm and dry year, and this provoked critical water scarcity in lots of territories and a general awareness of the risk of missing water. We have somewhere in our minds that France is a temperated country with full of water, and so that dry 2022 was a wake up. The government promoted his water plan in March 2023, and out of 63 planned actions, 5 concern reuse. So we have a dynamic for reuse, for water reuse, and with an objective of 1,000 reuse projects by 2027. But so that's a nice ambition, but it is a non-binding collective target. This is more a plan than an action. I come back to the different. So following this, we had everybody and every collectivity has been looking for reuse applications, and as I told, to reuse water, you have to have uses, and you depend also on regulation, because regulation is quite strict to protect health and safety, and sometimes regulation is a break to projects. To give an overview of different uses, first is direct and indirect potable water production, which is not authorized in France. We have one experimental project carried on by Vendéo, Projet Jourdain. The same way, groundwater recharge is not regulated. We have some experimental projects, but it is not as groundwater recharge is usually indirect potable reuse. It's not authorized. The second application of reuse is agricultural irrigation. This is regulated by Europe, Euro regulation of 2020, which has been adapted in French law in December 2023. We have numerous projects and ambitions of agricultural irrigation, but the business model is often difficult because agriculture has an access to quite cheap or very cheap water, fresh water in France, and so it's difficult to sell wastewater reuse, which is more expensive or less cheap. We have an operation, a very successful operation in the plain of Versailles, near Château de Versailles. Third use is landscape watering. So that's usually a urban or a peri-urban use for sport complex, for green spaces in town. This is regulated. This was regulated in France in 2023, and we have numerous projects. This is a good application, and some of them are ruling for some years, and this is working well. Then you have urban uses, which main application is cleaning, road or public utilities cleaning. This is not precisely regulated in France, not at the moment, but a strict regulation is to be published in 2025, which will not help projects. We have numerous projects because towns want to make it, but the volumes are small, and the economy is difficult to find. And last use is industrial, for cooling or process or cleaning. There is no specific regulation in France. There will not be. The authorization will be given project by project and plant by plant. There are some projects and one operation in Saint-Loubès in Gironde with ETEX. We are very proud of this, and we will present it today. And I will let Johan Hagen-Müller from ETEX present it.
Yeah. Hello, everybody. I'm Johan Hagen-Müller, Industrial Director of ETEX for the southwest of France. And I will present this project where we connect the wastewater to our plant. So this picture is a Saint-Loubès plant, a plasterboard plant. So you can go ahead, Cyril. First of all, a few words about ETEX. If you don't know this company, so ETEX is a global leader building material, as we have for Saint-Gobain or Knauf. And we manufacture different kind of materials. So we have 5 divisions: building performance, so plasterboard mainly. Exteriors is for roofing. Industry, we make fire protection, insulation, the insulation in the house, and new ways is a little division for on-site construction. So we have more than 30,000 employees and 106 plants all over the world. So I will present you the French organization. If you go ahead. So in France, we have more than 10 plants, but if we focus on plasterboard plant, we have 4 plants of plasterboard, and I'm leading the one in southwest of France, which is called Saint-Loubès, close to Bordeaux. This plant have mainly 35 years. We are in 5 shifts. We can manufacture up to 30 million square meters of plasterboard. We are close a little bit more than 100 people, and at the beginning we need to use 160,000 cubic meter of water. So at the beginning, it was only drinking water from the network. So in 2013, we decided to create some rainwater basin in order to reduce this drinking water, and we reduced to 140. And after, in 2021, just after COVID, we make an extension of the basin in order to reduce to 100. So we reduce from 60,000 cubic meter. But we were limited, and it's not possible to increase with rainwater. So we decide, because we have a wastewater really close to the plant, we decide to make the connection with this wastewater. At the beginning, the ambition was to reduce to 50,000 cubic meter, but it was quite conservative analysis. But in reality, now, from what we observe, we are close to 20,000 cubic square meter of drinking water, and the rest is for sure from the wastewater and from rainwater. So globally, we still use in total water 160. And due to this project, we got the trophy Plant of the Year in 2024 regarding the item CSR from a French magazine, which is called Usine Nouvelle. So just to let you know how our process works and where we use water. So to manufacture a plaster board is quite simple. We have the stucco and 2 layers of paper. The 2 layers of paper create the resistance of the board, and after the stucco to fill the board and to have something solid. So to have the stucco, it's a mineral, and we extract it from the ground with a quarry, and the material is the name of the material is gypsum. And when we heat it, it's transformed in stucco, in powder. So we have a quarry in southwest of close to Bordeaux, close to our plant, where we extract the gypsum and its rocks. We put it in trucks, and after it's delivered in our plant. So we heat the rocks and we break it in order to have a powder, but it's transformed in stucco. It's what we see at the beginning with the trucks. The red element where it's written calcination. After we mix this powder with some chemical product and with water in order to have the stucco. Okay. So it's totally liquid, and we put the 2 layers of paper in order to close it inside a kind of box. We have 300 of meter with some accelerator. The liquid is transformed in quite solid, but with high humidity. And after we cut it in order to have board, and we put in a dryer where it's in blue on the presentation, but it's called in French séchoir, and it's allow us to remove the humidity in order to have a total dry plaster board. And after we put in stock, we have some forklifts to put in trucks to deliver our client. So the point where we use water is where it's called mixer in blue, where we mix with some chemical and the gypsum. Okay? Exactly.
Yes.
At this part. So the project, we were at, as I told you, we were at 100,000 cubic meter, and we think at the beginning we can reduce to 50. So the project is to connect the wastewater treatment plant to our plant. So we have a picture here where we see the wastewater treatment plant, and in blue is the piping to go to the river, because this plant usually rejects the wastewater to the river. So in blue you have the piping, and the river is called Dortmund. So we had the piping in our plant. The little part, our plant is in orange with some point in orange, and the blue part is the piping we had to link it to our basin of rainwater. We had some filtration and treatment, so sun filter for the material and suspension of the water, and UV lamp in order to remove some bacteria we can have due to reuse water, to have a water 100% compliant with our process. So the water is totally clean for our employee, and we can use it like that with some with the station we have in the plant. So we connect from the wastewater, we connect after to our rainwater basin, we treat it, and after it's linked to our process in the mixer to inject water with the stucco. Roughly, the longest part was the administration work. We start just after COVID, the discussion with the town hall, with government, French authority, with some water agency. It took roughly 3 years of work with them, because we don't use to connect industrial plant to wastewater, so it's not easy to make the foundation and the basis of what will be the regulation associated. And after, once we sign the contract, the agreement, in 2023, all the civil engineering, all the investment, the capex was planned, and we start the project on site beginning 2024, 6 months to make everything, and the first water from wastewater was in July 2024. So now it's close to 9 months we use the water from the wastewater. In terms of capex, because this project is not have a cost, it's not easy, quite expensive. So it's cost a little bit more than 900 euros. So we need to take in account all the connection regarding piping to the wastewater. Sometimes you need to make a connection on the road. So you need also to have some validation from administration. We need to pay also all the filtration process for our employee and our process of utilization of water. All the electricity, pump, machine, automation, because my requirement is to have an installation fully autonomous. I don't want to have an operator make the setting and to have to calibrate the work. So it's fully autonomous, and we just have to have some supervision to do sometime 1 time per day in order to be sure everything is under control, and some alarm if we need to have some maintenance. All the civil engineering, because we need also to make to put the pipeline under the ground. So we have a lot of different work on the ground in order to have to make the specific requirement with piping, to pay the pipe, to also make the sludge treatment. So we create a new basin, but you have the picture on the right, in order to have to put the sludge in this basin, to don't treat it with another company. So it's to fully agree with the biodiversity we have here, and we pay also external consultant for that, because we are not expert in water. We are expert in plasterboard, so with stucco, with paper, but with water, it was a new topic. So we have an external in order to be sure all the design and the specific recommendation will be met. Also, we got a grant from Agence de l'eau Adour-Garonne that have been totally key in order to have this project, to make this project a reality. Go ahead, Cyril. Yeah, so in terms of synthesis, the key of success of this project, really the key was to work with all the French authority, country, town hall, water agency, the press, because everybody want to go to make this project a reality. No showstopper on that, but as it's totally new, it was not easy to make it really simple. Donc, so we need to be sure we put everybody around the table. We answer to the question in order this project can happen. And in terms of planning, also we need to be prepared. This project can take some time, at least 3 years. Maybe in the coming years, the timeline will be a little bit shorter, because some project will make the road in terms of administration rule, but for the moment it's quite it can take time. For us it takes 3 years. And after, but with climate warning, reduction of water is crucial. So for sure, if you have a plant and you have a risk of plant shutdown, we need to plan. We need to plan some project in the 3 years capex plan, or 5 or 10 years. After, in terms of capex, this project is quite expensive due to the price of the project is mainly linked to the distance of the wastewater to the plant, because more the wastewater plant is far from the plant, more you will pay capex and civil. You will pay piping and civil engineering. So we need to have a look of the ecosystem if we have something close to us. And also the interesting part, if you have from administration, you have a risk of plant shutdown during the summer, when water is a scarcity and there is a prioritization of water. This is interesting project, because you avoid the plant shutdown. And after, yes, the last point for us is important is to have the press, because we are looking to the press of innovation and project, and this is it's important to share all the good practice we have in regarding the industrial plant in terms of innovation, as we can copy paste after. It's more simple to copy paste than to make the innovation. So on ETEX also, we are looking also a lot of the press in order to have some innovation in other plants, not in ETEX, but in other plants, in order to see how we can copy paste the innovation to make it in our plant.
Okay, thank you, Johan, for that project explanation. Just one thing I want to precise is that the wastewater treatment plant of St. Lubes is a little one, 5,000 inhabitants, which is a testimony that you don't need a big plant to make reuse. It's not you have little scale and big scale. I will just go back on Zoom to reuse overview of what we do in France. As I told you, you have an ambitious governmental targets, but they are non-binding. So we're not sure it goes as fast as we would like. There has been for 2023 and 2022 regulatory adaptations, but regulation is still very restrictive. The enthusiasm of local representatives is huge, so that's the good point, and we and other made hundreds of preliminary studies and quite a number, dozens of demonstrating projects, like from 10 or 30 to 50,000 cubic meters per year. But the restrictive regulation and the fact that raw or even potable water stays cheaper, often cheaper than reused water, that doesn't allow a large development of reuse in France at the moment. We have a few large projects, like let's say 5 or 10, which produce from 1 to 500 cubic meters per year. So which have an actual impact on water resource. And we have only one very big one with 5 million cubic meters per year, which is in Nice, the Aliotis 2 project, new wastewater treatment plant with a very ambitious reuse. So we develop reuse. We will develop more and more, but this is still a bit difficult. The reuse opportunities, they depend very much on water scarcity level, on regulations, also on the quality of public potable water service. If the potable service is well managed, maybe there are less needs of reuse water, and of course of the potable water price. So what we can see maybe about this ETEX example is that water reuse improves an industrial resilience, but as there is no rapid return on investment, it's not a point for immediate competitiveness. To illustrate that those points of the opportunities and breaks for reuse, I will present you a non-typical reuse example, which is in Bora Bora, so French Polynesia, the Pacific Island, where we have reuse for a long time, 2005, and it's working very well. But I will explain you why that the example is excellent and non-typical. You have a severe water scarcity in Bora Bora, and so you have we have a desalination plant for 2003 or 4. The energy is very expensive also, and so the potable water price is very high, especially for luxury hotels. So in that context, the reuse plant, which we designed and built in 2005, which is a containerized membrane bioreactor ultra-4. This reuse plant is a total success because the reused water is less expensive than the salt water, and so the hotels especially buy it and use it for water the green areas, for fire protection, for roads and machinery cleaning, and we also use it for concrete production. That exotic example shows is a very clear example of conditions to where water reuse is critical and appreciated because severe water scarcity, high potable water price, and so good conditions for reuse. That's the end of our presentation, and thank you for your attention. We shall answer your questions.
thank you very much to Cyril and Joan.
We don't hear you well.
Yeah, Pavita, the mic again.
Sorry.
Yeah.
Thank you so much, Cyril and Joan. With very interesting presentation, and actually what the participants were looking for. We cover from regulatory aspects and strategy in France. So it was indeed very interesting to see how France is developing the water use strategy beyond the agriculture irrigation in line with the European regulation, and also how ETEX reduce the withdrawal of drinking water for the production of plaster. Sometimes I'm still thinking, how come we are using drinking water for producing gypsum or concrete or paper? So that was very, very interesting. Also, well, I believe that everybody will wish to visit the Bora Bora reuse plant one day. So in case you have a yeah, we wish to have a tour there. Anyway, there are many questions, and we are only 12 minutes until the end of the webinar, so we will go through some of them. Some of them they ask about French requirements. Some they go more in specific details of the process of reusing water in ETEX. So I will go to. Well, one about strategy. There is one question on the 1,000 non-binding objective reuse projects by 2027. Do you know, Cyril, how many they are currently have been implemented or being executed, and if the PFAS regulation is affecting these reuse projects?
So it depends a little bit of how we count them. But if we speak about wastewater reuse in France, we are a bit less than 200 operating. Some of them are very little, some of them are quite old. But so that's about 200. The regulation, which French regulations for reuse, which is like a copy of a EU regulation or an adaptation of EU regulation, does not take micropollutants and PFAS into account. It is only focused on health, human health, and of operators and the environment. So it's only focused on microbiology. It's very severe on microbiology, so it can lead to membrane treatments or an important disinfection. But it's not focused on micropollutants at the day.
Okay, and this will lead to another question. If you had looked to specific requirements for the water that for the process of the plaster production and how these were determined, it was by regulation or by risk management, risk assessment?
Just before letting Johan complete, because he knows the project precisely, just there is no regulation in France for industrial reuse. It's just a project by project.
Yeah, exactly. On my side, it was more to check to remove any parameter that can have an impact on our process of manufacturing. But after the other, we don't consult any other regulation. Then the only regulation we got from the government was to be sure there is no bacteria. It's for that we add the UV lamp.
Okay, this was for the production of the workers in the factory mainly, and the other parameters that you determined was to get the exact water quality for the plaster production.
Exactly.
Do you know, there is a question regarding about the water balances. Do you know how much of the effluent you are withdrawing from the municipal wastewater treatment plant? And if this additional withdraw from the plant affected the river flow?
Yeah. we make the calculation for that because we got the question also from the government, and I don't have the calculation under the ACE, but I remember it was below 0.007%, something like that. So it was negligible.
Yeah, that's a question because of water scarcity and because the reject of the wastewater treatment plant is in a river, Dortmund, but this is a little treatment plant, and the Dortmund is a big river, so there is no effective problem about this.
Okay, thank you. And is the recycled water used only for plaster production, or there are any other uses in the process?
No, only for the plasterboard production, only for it.
Thank you. And there is a question on regarding capex. Do you have a specific cost for the sand filters?
Yeah, it was the main cost on the sand filter. All the treatment, it was close to 300 euros to put it everything in there but to be sure there is no issue with the water. And also I see a question linked to the quality of the water, and we were quite surprised because in our imagination the wastewater, me also, is not good water. But it's not good water. The water is not perfect. And in terms of quality, when we look at it, it was close to the quality of rainwater, in fact. And I think we have in imagination, it's for a lot of people, it's we don't know exactly how it's work. In fact, it's quite good. So it's not water you need to drink as a rainwater. You don't drink it, but in terms of quality, the quality is quite well good. So with the also filtration and the UV lamp and so on, the water is okay, fully okay.
I must thank Johan and say that his intervention was not prepared, but we make quite a good job at treating water, and it's true that lots of water treatment plants are not fully charged, so they have very good bacteriological results, and also there is no regulation for industrial reuse in France, but the regulation for irrigation or watering is much more exigent, demanding than for sports and leisure, and when you go to swim, so swimming waters. So this is a very demanding on wastewater reuse.
Yeah, exactly. And for that, because we present this project with the unions in our plant in order also to be sure there is no social impact. And when we present the result of the wastewater before treatment, after treatment, because we make analysis every month on the water linked to more than 100 criteria. Okay, so it's really look every month. We present that to the unions, and they are quite it was a no-brainer, no question. Everybody understands that the water is fully okay, and there is no risk at all to put it in our process for the process and for the employee. Plus the treatment we put in place, fully okay. No issue at all.
Thank you. One of the question was as well, or at least try to combine some questions as we're running out of time. Would you or do you plan to expand this project to any other of you, let's say, sites, and to mix it with another one? What would you say on your based on your experience, what would be a no-go, or what could be done better to maybe gain some time to make it a bit easier to implement it?
Yeah, but we present this project at group level in order to share the good practice. The project is really interesting for some plants. So some plants are already making some assessment if they can do it and how much will be the investment. So yeah, I think it will be deployed, but after, as I told you, it will take time in terms of planning. After in terms of go no go, it's as I told you, only the distance. If you are close, it's kind of interesting. If you are too far, after you need to find some of the alternative, because after the price will be too much expensive. So I think a good distance is 1 kilometer. 1 kilometer need to be a maximum for. After it depends of the rule of capex and sometimes, but and the risk of water scarcity regarding to the plant, but yeah, more than 1 kilometer after it can be complicated. And depend of the country also. After the investment will be not the same in all countries. But in France, yeah, I can say.
But they are very local and territorial projects. It depends very much on the local context.
Exactly. And it depends of the grants also you will get, for sure.
Thank you.
Yes, Arthur, I will also try to merge some of the questions. There are many questions regarding CAPEX and OPEX. Mainly the question is about yes, is what are the costs for cubic meter of reclaimed water produced?
This is confidential.
Okay.
But yeah, I look to the question linked to OPEX, but OPEX is really little. The cost of electricity, we just have few pump, so it's not big pump, so it's not really important. And in terms of maintenance, we plan some cost, but the station is fully new, so up to date it's more like control of some equipment, but in the OPEX we plan, I think, if I remember, it was 10 kilo per year in terms of maintenance. So not that much. Only it's a more one-shot project with the CAPEX.
Thank you. And I'm looking for. Do you have any specific contracts between the water the wastewater treatment plants operators and ETEX? I would try to.
Yes, we have a convention with community and the operator SUEZ and the plant ETEX. The convention is very simple because the treatment is done by ETEX. So in other conditions where we have to make all the reuse treatment, convention can be a bit more complicated. But that convention is simple.
Okay, and was environmental risk assessment and modeling of water resources into the future, 5, 10, 15 years into the future of groundwater availability required for the permit for this project in France? Yeah, see, you are reading the questions. It's more related to France permit and governance, if this was a requirement, a specific assessment on groundwater.
I'm sure to fully understand the question.
It could be, but go on, yeah.
No, yeah, there is a risk. After there is in France, there is a risk of when we have a crisis of water during the summer, the government asks us to reduce the water. We have several level of restriction. So it can be you reduce by 10%, of 20%, 50%, or you don't use water from the network. So, and from the analysis we had, in the coming years, it will be more and more difficult, and we will have, and the level today, usually during the summer, we used to have a restriction of 10%, sometimes 20%. But we can imagine in 5, 10 years, and it will be more difficult. And we imagine close to 2040 or 50, it will happen, maybe not every summer, but frequently, to have a total risk of plant shutdown. So it's for that also we put this project. We were in ETEX, we were a plant quite advanced in terms of water reduction. And so we were sensible to this point. And when we see SUEZ with the wastewater just closed, so we got the idea to contact them for that. But yeah, we need to have plan due to that. We need to be prepared.
Are there any funding schemes for industries as incentives in France for reuse?
The same plan I presented, the same. The objective is to reduce. To have each industry has to have a water plan, a water reduction plan, and the objective is to reduce from 10% the consumption. So as you can see, ETEX does much more than this. And so with the objective also to reduce it more, like 50% reduction for some big industries with much more water recycling. So it's yes, there are some objectives, and there is a big job done for recycling in industry.
Okay, Arthur, would you like to? Did you get any other questions?
I think we have one just, but really maybe 2 sentences, Cyril, on can you explain again why Bora Bora was a special case of a non-typical reuse example, and then we'll stop there.
It's just because it's a very quite isolated and little island with a huge tourism activity, and so as we have no water or no sufficient water, and no local energy, which means very expensive energy, the water price in Bora Bora is totally untypical, much higher than anywhere in France, not anywhere, but the average in France, which allows projects of non-conventional waters, dissolved, reused. So that's why it's really non-typical in France. It's like even if Bora Bora is very green, it's just maybe we could say that the context is typical for Pacific or some places in Australia, or we have a very high water scarcity compared to other places in France. That's why it's not typical.
Thank you.
Arthur, I believe only a final comment for people that probably joined later, if the presentations and
so presentation will be available, will be shared with all the people that registered, and there will be a recording on the EWA YouTube channel if you want to listen to everything again that we discussed today. And I think you have just reached the end of our webinar, so I will just share one slide to share with you 2 points before you leave, please. So first of all, I would like to inform you about our upcoming events, either online and in person in Oslo. So we have a webinar on EU water resilience strategies that you mentioned earlier, Roberta. Then our spring conference together with our Norwegian national members on the Urban Wastewater Treatment Directive recast. Again, you can find us on LinkedIn, on YouTube, if you want to have a look at the recording from today that we'll be sharing in a few days. And our website, you can subscribe to our newsletter, and at the end of it, you will have a survey. So please help us to increase the quality of our events. And I would like to thank all of you for staying the 7 minutes extra, and also really big thanks, Roberta, for everything in taking care of organizing this event with us today. And to thank you for all of our speakers, especially Cyril and Johan, that are still with us today. And again, it's been a pleasure from the EWA side. We have been always supporting the water reuse regulation, and we'll keep doing so in the future. So thank you very much to all of you.
Thank you very much to everybody, all from our side, and to EWA for hosting the event this time. And we are looking more for further collaborations. And thanks, and have a good day to everybody.
Thank you. Good day. Bye-bye.
Bye.
Bye, Cyril and Jean.
Yeah.
Thank you very much again.
Thank you.